one container. I can launch a few containers, Windows, Ubuntu, whatever your favorite operating system is. You can easily fire up a handful of containers. But when you're running these containers at scale, when you are somebody like Pinterest or GoDaddy, where you are running hundreds and thousands of containers at scale across a huge cluster of AWS, that's when these challenges are. You need to make sure that somebody is managing your cluster. You need to make sure somebody is scheduling those containers. You need to make sure that the containers, if they go down, somebody brings it back up again. So those are some of the constraints that you need to be aware of. You also need to make sure that the containers are able to talk to each other. I mean, at Amazon language, we call that as undifferentiated heavy lifting. What that means is, as an app developer, your core focus is to build the application and run the application. All that is noise for you, because that kind of distracts you from the main purpose of the job, which is building the application. So that's where the undifferentiated heavy lifting is what EKS provides. So let me kind of give you at a very high level what is our container strategy. Now, in 2014, we announced ECS, which is our own managed service, which is Amazon's managed service. There was no Kubernetes at that point of time. Our customers were asking us. Amazon is a customer-obsessed company, and we truly talk about customers every day, in and out, multiple times during the day. So our customers were asking us, help us run Docker containers at scale. That's the reason we launched ECS. Today, there are hundreds of millions of containers that are launched on ECS in a given week, and it runs at a huge scale. Then Kubernetes kind of started gaining popularity, and it's quite popular among the developer mindshare today. Again, our customers ask us that running Kubernetes is hard. Run Kubernetes for us, and that's the reason we said, okay, we're going to offer another offering here, which is ECS or EKS rather, which is a managed Kubernetes service essentially from Amazon. Now, you can run these services in a way where you can bring your own worker nodes or where your containers are running. That's the EC2 mode, where you bring your own EC2 instances, attach it to the ECS or the EKS control plane, and that's sort of where your load is running. Or the other option is Fargate, and I'll talk about that technology a little bit later, where you don't care where the cluster is running, you don't care what the EC2 instance types are, you don't care about how the upgrade, patching, management of all that is happening. You just say, here's my container, take it and run it, and scale it. So think of it as like a serverless containers, where you don't worry about, you just bring a container and you run it. We take care of upgrading, patching, management of the entire infrastructure for you. So today, if you look at it, we provide, ECS today can be run in two modes. There is the EC2 mode, where you bring your worker nodes, attach it to the control plane, or the Fargate mode, where you just create an ECS cluster for administrative purpose. But in the Fargate mode, you just say, here's my container, run it. And then, of course, EKS runs today in EC2 mode. I'll explain that a little bit more. But the Fargate mode is the work that we're doing with the community, and I'll kind of give more background on that as well. So what is Kubernetes? Now, Kubernetes is a container orchestration system that was originally built by Google and then donated to CNCF. It's one of the most popular projects on GitHub, and it is indeed the most popular project by CNCF as well. It allows you to run containers at scale. It also gives you basic primitives, which allows you to build and run your application very easily. So you can easily take your existing monolith, split it into multiple microservices, and it gives you that ability and those primitives by which those microservices can talk to each other using the Kubernetes primitives. It's a very cloud agnostic way of running your application. You can run it on-prem, you can run it in any cloud provider, although we prefer Amazon, and I'll talk about that number a little bit later. It very easily kind of transcends to build you a cloud native application. So if you're using, particularly as I was saying earlier, if you're using microservices to build the application, it very easily allows you to migrate your application in a cloud native way, run it in a cloud provider of your choice. Now, where you run Kubernetes matters, because Kubernetes is not, running a Kubernetes cluster is not for the faint of the heart. It requires a lot of infrastructure that needs to be set up. So which cloud provider you're running Are your customers around the world in a global scale? Are your customers in a region where the cloud provider really exists? The quality of the application matter. Can your application really scale up? If you are spinning up all of a sudden a huge cluster, does your cloud run out of capacity? So those are some of the things that you need to think about when you're spinning up your Kubernetes cluster. Okay. Now, there was a CNCF survey done last December. That is the most recent CNCF survey, and there it was said that 57% of Kubernetes today runs on AWS. And by the way, this is purely organic without any active involvement from AWS. These are tools like Kops, which allows you to easily set up a Kubernetes cluster. Kubeatom, or there are like 18 different varieties of tools by which you can easily fire up a Kubernetes cluster, but still running on AWS. So let's try to get a feel, what does it mean to run a Kubernetes cluster, not just on AWS, but anywhere. Typically when you will set up a Kubernetes cluster on AWS, say in this case, you want to set up a highly available control plane. First of all, step back. Kubernetes, when you're running a cluster, consists of two pieces. One is a control plane, which is sort of your master, so to say, and then there is a data plane, which are the worker nodes, which is essentially where your containers are running. The containers do not run on the control plane. Now, when you are setting up a control plane, you want to set up a HA control plane. What that means is, in typical AWS lingo, if you are setting up a control plane in a region, we have this concept of a region in AWS, and we have 18 regions around the world, which is basically a physical location around the world where a cluster of data centers. And each region, in that sense, has multiple availability zones, or AZs. Now, those availability zones are within a region and connected to each other using low latency links. The whole idea is, in case of a disaster, you can fail over to another availability zone, and we build enough bandwidth, enough network connectivity between them, so that in case failover happens, you can still handle it. So, running a HA control plane, what that means is, you pick a region, you set up, 3 masters in 3 different availability zones. So now you're running a HA control plane in an AWS region. Let's look a little bit deeper into what are the key components for the master are. If you're running a master, there is an orchestrator, there is a scheduler. Let's see if I can do this, yeah. There is, first of all, API server, because that API server is the one that is receiving the request from the client. And what is it that needs to be done? Because at the end of the day, Kubernetes is an API. That API needs to be understood by somebody, and that is the job of the master. So the master reads that API and says, oh, you want me to deploy a container. Let me translate that into Kubernetes lingo and give the commands to my underlying slaves. It has a controller manager. So you want to say, for example, I want to run a container, and I want to run 3 replicas of it. So the controller manager will then make sure that, okay, there are at least 3 replicas of it running at a given point of time. In case a container dies, or rather in a Kubernetes lingo, a pod dies, it's going to bring up the pod back up again. There is, of course, service discovery using kubedns. There are schedulers which say, oh, you're running a 10-node Kubernetes cluster where a pod needs to be run, which particular host is going to run on. So there's that part of it. There are, of course, add-ons and cloud controllers where how you connect to a particular cloud. So there are a lot of components in the Kubernetes master that you need to run on. Well, master is one part of it. The state of the master by itself is stateful, but the state of the master is now persisted in an etcd store. So what is etcd? Etcd is nothing but a distributed watchable registry. So as you give a command to a master that create a pod, it does not create the pod right away. It takes the state of the pod and it stores it into the etcd registry. But then there is a controller manager which then looks at the registry, says, okay, you know what, I'm going to pick up that information and I'm going to create the necessary constructs. There's a beautiful rundown that is written by a GitHub engineer, and I think I tweeted about this a few weeks back, which exactly explains what are the key components of Kubernetes kick in, what really happens in the sequence when you say kubectl create a pod. It's a beautiful rundown, very deep dive, and if you're really into Kubernetes, I would recommend reading that. But essentially, the state is stored in etcd, controller manager is then looking at the state and then says, okay, now I'm going to schedule this pod. And then finally, you have worker nodes, where the containers are actually running, because master is only for the administrative purpose, etcd is for the state, and then worker nodes. If you were to build an application, if I ask you to set up a Kubernetes cluster like this, how do you do this? I mean, should my etcd be co-located with master on the same host? What should the size of my etcd look like? What should my instance type look like? Should I really master be split across 3 AZs? What if, I mean, in Kubernetes lingo, they talk about if the number of pods in your cluster are increasing, then you should change the instance type. Should I manage it? Somebody else manage it? And how often do I change it? Day one is fun. You are deploying one particular version of Kubernetes. Day two, now there's a new version of Kubernetes which comes out every 3 to 4 months. How do I upgrade my master? So there are, and above all, think about what are my AWS best practices? Am I using the right practices to deploy this cluster? So there are a lot of things that you need to be aware of when you're spinning up a cluster like this. That's where customer comes to us and says, what? It's too hard running a Kubernetes cluster for us, run it for me. And we are, as we said, we are a customer-obsessed company. That is exactly what drives us to create our new services. Roughly 90 to 95% of our roadmap is driven by customers. Now, when we build this service, there are some of the core tenets that we are very strong about. So the very first tenet essentially for EKS is, this is the platform where you can run your enterprise-grade workloads. What I mean by that is all the abilities, scalability, reliability, high availability, performance, a large-scale cluster, and some of the biggest enterprises in the world are Amazon's customers. They give us this feedback that we want to have that ability to run that workload on Amazon. So this is one of the core tenets. So if you can run it on a Kubernetes anywhere, and if your scale that you think should run on Kubernetes, it should run on EKS, period. The second core tenet, which is fundamentally important, because that's sort of the reason why Kubernetes is so popular, is built purely out in the open source. The engineering meetings, the community meetings, the design discussions, all of that very heavily happens in the open source. Yes, there are some tribal gatherings, but there is more and more emphasis these days how those tribal gatherings can be minuted and documented so that it becomes a much more transparent process. So that's where the second tenet is important, that we want to provide you an upstream experience. As a customer, let's say you're running Kubernetes on-prem for your test and development. Now you want to just migrate that seamlessly to an EKS cluster, because you feel that is a undifferentiated heavy lifting, and you want somebody else to be responsible for managing the control plane for you. So now you can actually use the skills to build it internally on your laptop, for example. I play with Docker for Mac on my machine every day, which has a Kubernetes single node cluster available for me. And then you can seamlessly transfer that skill running in the cloud, because it's a true native upstream experience. That means no forking of Kubernetes. That means no internal branches of Kubernetes, none of that. Everything that we do, we contribute back to upstream. Now, AWS customers are very used to integration, a very deep and wide integration across different services. So we're going to provide that integration of all the services. Think about CloudWatch, think about CloudTrail, think about IAM, think about different services, code pipeline. So we will provide integration with all of those services, but that's not the essence of it. We have done the differentiated, undifferentiated heavy lifting for you. If you want to use it, you can use it, but not really a requirement. And the tenet that I'm most excited about is this one, where I'm saying that the EKS team is actively going to contribute back to upstream. That is the fundamental change at Amazon here. Anything and everything that we're going to launch in EKS managed service is going to be done out in the upstream. Because there are, again, that's sort of the whole premise of saying there is no internal branches or workspaces that are being maintained essentially. Okay? So if I take a look at it essentially on how this thing is worked, as we talked about, there's a control plane, which is master and etcd, and then there's a data plane. So when you come to AWS console and say, give me an EKS managed cluster, AWS manages your control plane, and on the customer account, which is you basically, that's where now the data plane is being managed. So we expect that you will bring your EC2 instances, and then you will attach it to the control plane. So it's a two-step process. First step is where you create a control plane. Second step is you bring your worker nodes and you attach them to the control plane, and that's it. So it's a split account essentially in that sense. So what you get in that sense is you get a Kubernetes URI that as you get with an API server, and then in the different availability zones, you can easily set up your worker nodes and attach them to the control plane. Okay. All right. So the process is like that. Once again, you create a control plane that is done on the AWS console or AWS CLI, and then you bring your worker nodes and you attach them. Those worker nodes are running in your account. The sizing and all of that is upon you, but we provide CloudFormation scripts, and we are working with our partners. I think right at the launch itself, we had Terraform scripts available as well. So there are multiple ways by which you can connect with it. The important part to understand here is EKS is a 100% certified Kubernetes version. What that means is if you are running on Kubernetes upstream, those applications would run exactly as is, unmodified on an EKS cluster. And once again, leveraging the skill set, leveraging the expertise that you have built on Kubernetes over all these years or months, we want to bring that expertise and be able to leverage that into the EKS cluster. So I've gone through quite a bit of concepts. Any questions so far?
So EKS is with Fargate. So what is the timeline like?
That's TBD. I'm going to talk about that later in the slides. Yeah.
Yeah, between tenant 2 and tenant 3, contributing code back to Kubernetes project, and you're integrating AWS services. Are you contributing code that's unique to AWS, or are AWS services being modified to fit in the Kubernetes ecosystem?
Yeah, the question is, what is the difference between integration with AWS services and contributing back to the upstream? I think those two are separately unrelated items, because the point is that if we want to add a feature to Kubernetes, we will do that in an upstream way. So we will only contribute it back to the upstream. But if there is any integration that, let me give you an example. The way when you bootstrap the cluster, by default, you can only say kubectl authenticate with the cluster without any AWS account, okay? Without any AWS IAM. We work with our partners, which is Heptio. We created an AWS authenticator. So now this is again done in the transparent way. There were changes that were required in client Go library that we had to make. Again, pushed upstream. Heptio authenticator again pushed upstream. So all those changes were pushed upstream. So now if you download stock kubectl 1.10, it allows you to use IAM as an authentication mechanism that is not just available for an EKS cluster, but for anybody else as well. So that's sort of the key part. But there are other integrations that we are looking at, for example, code pipeline, which allows you to build a quick deployment pipeline. That is a managed service, and so those integrations, of course, will be done internally.
You bring your own workers on the EC2 nodes, that's only the workers, or the master nodes too are under
The master is completely, the control plane is completely managed, and Amazon takes care of it. You only need to bring the worker nodes.
So your billing is mainly on the worker nodes and not the master.
Well, there is a billing for the control plane as well, which is about 20 cents an hour. And then master worker nodes run in your account, and then you bring it on. But the whole point of running a managed control plane is fully managed. If the masters need to be updated, managed, patched, we'll take care of that.
And you get redundancy, you get HA.
Correct. etcd is regularly snapshotted, backed up. If things go down, then we bring it back up again, we take care of it. From your perspective, what you're getting is one API server URI, and so your usual kubectl, which is the upstream experience, will continue to work as is.
In general analysis, how you compare that approach to Google's and Microsoft's Kubernetes?
We are all about customer focus here. We really don't look at competitors that way. It's about what are the customer requirements, what are we fulfilling over there. And I can talk about it a little bit later. When EKS limited preview was announced December of last year, we had a huge interest from customers all around the world. And we have about 60 customers that participate very actively in the limited preview, and I'll share some names around that. So what does Kubernetes conformance really give you? Well, first of all, guaranteed portability and interoperability. Everything that you have been doing on-prem or any other cloud provider for that sake. If you like the reliability and the availability of Amazon, you can just seamlessly bring your application to EKS, and that will work out of the box. You also get timely updates. So if that means, if we have, say, 1.10 version available today, by the way, that's how we launched with 1.10 compatibility, which is the latest version of Kubernetes. But what that means is when 1.11 gets released, and when we announce 1.11 in there, then you'll have 2 versions that are available to you as a choice. But we need to make sure that we validate the version appropriately, but you would get timely updates as well. So if I look at what sort of my API description looks like, as I said earlier, the Kubernetes cluster can be created using console, which is the AWS console, and can also be done using the CLI. Now, what I have is an EKS cluster, and I got 4 different nodes over there. This is a 4 worker node console, 4 worker node cluster first, essentially. So let's take a look at my API. So here, what I'm doing is I'm saying AWS CLI. I say EKS, which is my subcommand, and then I'm saying create cluster. So then I'm saying create an EKS cluster. I give it a cluster name. In this case, it's re:Invent 2017. I can give it a desired master version. This one would fail actually right now. This command as is would fail because the only version that we support today is 1.10. So you're going to say desired version 1.10, and then you give it a ARN, the role on, the IAM ARN. That okay, here is a role on how I'm going to be authenticating with the cluster. So these are some of the key parameters that you need to specify as part of the API. And then we'll give you more details about the cluster. It takes a few minutes behind the scenes to provision those 3 worker nodes, provision the etcd, make sure they are connected and all that. You can of course get, say, AWS EKS describe the cluster, and it can give you more detail about the cluster, of course giving a cluster name. And in that sense, what you get is really a more detailed JSON message. I'm getting a cluster name, the created and current and desired master version. I mean, right now it may not be directly relevant because what we are doing is we only have 1 version. But in future, when say like 1.11 gets released, then you could say, oh, by the way, the current master version is 1.10, but the desired is 1.11. Maybe it's during the upgrade cycle that you got this describe cluster API, and that gives you other details about the master as well. Of course, we got the usual CRUD commands, so you can say EKS list the clusters for me. And you can, of course, delete the cluster as well. Okay? So those are my basic APIs. And the experience for getting started with console is very similar as well. I can just go to the console and I can say, create a cluster. It asks you, what is the VPC ID that you want? What is the role-on that you want? And then it creates a cluster for you automatically.
Anyone mentioned that that's changed? It's not cluster.
Yeah, the API is a little bit stale in this particular slide. Yeah. So let's talk about a little bit about the EKS architecture itself. Now, in terms of master, yes, we give you a highly available master control plane, and what you get is 3 masters and 3 etcd nodes. And as I was talking about, we chose a reasonable instance type for you, but we are constantly monitoring, how the instance is performing essentially. If there is more nodes being added to the cluster, if there are more pods being deployed to the cluster. So there are certain CPU and memory metrics that we monitor, and in case we need to add a new master to handle that capacity, we take care of it automatically for you. Now, once you have the control plane, we do provide integration with both CloudWatch and CloudTrail. And what that means is that when you're running your clusters, all your commands, if there are any log outputs from your containers or the pods, they are automatically directed to your CloudWatch, because that's sort of the AWS language that developers understand, so it's automatically redirected over there. And your AWS EKS command, which are the CLI commands, and like if you're creating a cluster from the console as well, those automatically go to CloudTrail. So we provide CloudTrail integration out of the box already. CloudWatch is the integration that we are actually working on right now. Let's talk a little bit about the authentication mechanism and how does the authentication mechanism work like. Now, if you think about it, there are 4 components here. There's a kubectl, which is sort of my CLI and how I deploy applications. Then there is a Kubernetes API server, which is sort of my cluster where the cluster is running. And then behind the scenes, I have an AWS Authenticator that is as a managed service for me. And then of course I have a Heptio AWS Authenticator, which allows me for the kubectl to talk to the AWS Authenticator. Okay, so let's see how does this work. Now, from the kubectl, essentially what you do is you pass AWS identity, which is your IAM arm. Behind the server, the Heptio Authenticator kicks in, it talks to the AWS Authenticator service, says, okay, I'm going to verify the AWS identity. This is purely authentication at this point of time. Okay, so I'm just doing authentication. Once the authentication is done, then you can actually do a connection using RBAC, which is a standard feature in Kubernetes API now. You can do the authorization using RBAC. And then, whether your actions are allowed or not allowed, the response is returned back to you, the client, essentially. Now, the cool part about this is because all the work is done out in the open source, all of this functionality is available to you out of the box. You just need the Heptio AWS Authenticator, and the stock kubectl works out of the box for this. So you just need a role arm.
Is the RBAC the IAM policies or?
This is RBAC feature in Kubernetes. Yeah, Kubernetes RBAC. Yeah. One of the key fundamentals at Amazon that we follow is we don't try to reinvent anything if it already exists, and that is particularly true for Kubernetes. And when Kubernetes, if the capability already exists, then we'll just leverage that as is.
What does RBAC stand for?
Role-based access control. So essentially what you have done is, in this case, you say pass a AWS identity, which is a role, then you get a role back, authenticate it correctly, then you use that role to tag into, based upon that role, what all capabilities I have.
That's probably not an IAM role, right? Kubernetes role.
No, in this case is an IAM role, but then you map the IAM role to a Kubernetes role, and then you say, okay, how does that mapping value work like? Now there are mechanisms like Kube to IAM, essentially, that a lot of our customers are using. We're not super excited by that at this point, but that's sort of the primary means how it is being used. There is KIAM, that's a similar tool, where you can assign an annotation on a pod and say, okay, when the pod is running, here are the IAM permissions I give to the pod, because now you can talk to RDS, but you cannot talk to DynamoDB, for example. So that is okay, but essentially the problem with Kube to IAM particularly is it opens up your security gateway big time, because you require really allow permissions to run on a particular host.
Does that Kube to IAM replace Heptio?
No, it doesn't. That's a completely separate thing, because this is only during the cluster authentication. But once the cluster is authenticated, then when you're running a pod at the runtime, at that point you can say, for this pod, what IAM permissions it has, because that really defines on which services you can talk to or not.
Sorry, so maybe you said this K2 IAM, right? So I'm not sure I got the name, but when these worker nodes are taken a role, will the pods take the same role, or can they take?
In the deployment spec, basically what you need to do is you need to define an annotation and basically put the role arm into the deployment spec.
Okay.
So you say assume role on the pod, and then on the pod you have given a specific role, and then the pod will take that role. So it doesn't matter where your pod is running, each node needs to have that assume role, and that's the security hole we don't like. In the long run, what we are looking at things like Spiffy and Spire, which basically defines a portable container identity framework. So that's sort of, again, one of the things that we've been working with Heptio on.
That's some CNC of one of the new.
Correct. Correct. It's an incubation project at this point, yeah.
So, can you configure like multiple roles, or because when I see like create cluster command, I see you are adding only one role.
So for cluster authentication, only one IAM is permissible.
But if I want to have like somebody is an admin and someone else is just a reader.
And that's where you get into the RBAC part of it. Remember, you can create one IAM role, and only cluster authentication is with that at this point.
Okay.
But once the cluster is created, what you are allowed to do or not allowed to do, you can still configure that with RBAC. Like, okay, you can add a pod, or between such and such time, you are allowed to deploy a pod or create a database or not create a database. That can be handled with RBAC. But at the cluster administration level, one IAM role at this time.
Okay. Okay, so you're saying like there's a human interaction with the clusters, and then there is a containers interaction with the services, like creating creating.
But you're hoping that your clusters are not automatically being created, so somebody is manually creating it, and that's where the human interaction kind of comes in.
But after all, it could also be API.
Again?
It could also be API client.
No, totally. But then in that also you will put the role at least, when you're running created cluster.
Is there any limit on the number of clusters you can create in an account?
So no physical limit per se, but if you want to really create a large number of customers, I really recommend talking to the account manager and work with us, because all the customers that we've been talking to, whatever number of clusters they want to create, we have been able to help them out. And some of the biggest enterprises, as I said, are Amazon customers, so we are happy to work.
So like if you have to create a cluster per shard on our side, you probably have like.
It's your use case. Whatever your use case is, we're happy to support it. And that's sort of the first tenet of the service that I was talking about. Jeff Bezos says, all customers in the world are beautifully unsatisfied, and it is our job to make them satisfied. So any of your requirement is our requirement, and that's what defines our product roadmap. Now, look at Kubernetes a little bit more. How does the networking within Kubernetes work? They have defined a CNI, or container networking interface. Is that better? Okay. I was trying to protect you from the sunshine. Yeah. So CNI, which is container networking interface, and that's a standard interface how containers can talk to each other. Now, when you're firing up a Kubernetes cluster, there are like 8 to 10 CNI providers. You can use any of those providers and configure your cluster. Back in the Amazon world, customers love the VPC networking. So what we created is, we created a simple CNI plugin, which gives you first-class VPC networking for Kubernetes containers or pods. What that means, I don't know. Let me see if there is a slide which explains architecture. Yeah, there is a slide that explains architecture. So essentially, pods, each pod gets an IP address that is from the flat VPC network space. All of your worker pods, now they are in a VPC. Now remember, when we're creating a cluster, we give a VPC ID, and then each pod is assigned a unique IP addresses from that VPC. So then a pod-to-pod communication is a requirement for Kubernetes, and that just happens very easily within the VPC itself. So how does it work? Well, let's say you have a 2-worker node cluster here. Of course, the CNI plugin is running as a daemon set. So we have a CNI daemon set running on each of the workers. Now, in the Amazon language, we have ENI, or Elastic Network Interface. So each worker node is assigned an ENI. The number of IP addresses, or the secondary IP addresses that each ENI can allocate, is predefined. So you can say, here is a M4 large instance type, I'm attaching an ENI, here are the number of IP addresses that I can attach to it. Now there's a formula, like we reserve first a couple of IP addresses or so for Kubernetes networking and for EKS. But essentially, you have an ENI, you want to fire up a pod. I'm spinning up an Nginx pod, another Java pod, another Nginx pod, another Java pod. Okay? The CNI, which is container networking plugin that we created out in the open source, and I say, okay, I want to do the VPC networking over here. It really talks to the ENI. The ENI is what gives it the secondary IP address. That secondary IP address is basically attached to the pod, and we connect it to the veth, and then let the Linux kernel take care of the rest of the magic. So all we're doing is we're getting a secondary IP address, we connect it to the veth of Nginx pod, and then everything happens as it's happening in a typical Linux system here. Yeah, once again, this is done out in the open source. So if you are spinning up your own Kubernetes cluster, you can use the same CNI plugin to configure it yourself. So for example, if you want to spin up your own Kubernetes cluster using COPS, you can use this CNI plugin. And the advantage is, let's say you want to minimize the impedance mismatch between your dev cluster, which you're finding up yourself, versus the prod cluster where you are actually using EKS as a managed service. Okay, the animation keeps going. All it's saying is there are different IP addresses attached to different hosts. So that's the CNI part of it. Now, think about a Kubernetes cluster where you have multiple applications running. How do you define which pod can talk to which pod, or which applications can talk to which applications? And that's where sort of the Calico, which is a project by Tigera, their implementation comes in handy. It really defines a firewall between different pods, and it uses a very flexible way of defining how the firewall would work. All it says is, if a pod, everything in Kubernetes language, a pod has a label, and that's sort of how the pods are identified. And that's the same semantic that Tigera has, or Calico has really adapted. It is commercially supported by Tigera, but essentially it allows you to enforce policies on which pod can talk to which. I think I have a slide here, yeah. You can very clearly define using Tigera policies that, okay, if your pod has such and such label, then you can talk to such and such pods with another set of labels. So you can very easily define those network policies, very fine-grained firewalls. Think about a bigger Kubernetes cluster and running multiple tenants over there and saying, defining and locking down the scope on which apps can talk to which. And by the way, this is available to you out of the default. When you fire up an EKS cluster, you have Calico as a plugin already installed. One of the common themes that customers ask us is, what is sort of the upgrade philosophy now? Now, the slide is a bit old because it talks about 1.9. We only support 1.10 at this point of time. So that's one of the first clarifications I'm going to make here. Now, if you look at the Kubernetes versioning scheme, there is a major.minor.patch release. That's sort of the number. So in this case, for example, 1 is a major, 10 is a minor, and 192.2 is the patch release. We only give customers the choice for a major and a minor version, and we don't give the choice of a patch version, because patch version is typically where CVEs, bug fixes, etc. are available. So when a new patch version comes in, and we know that we have already validated it within the EKS team, passed AWS security benchmarks, etc., then we just automatically upgrade to the latest patch release. So no choice in that. But if you want to migrate from 1.9 to say 1.10 to say 1.11 when 1.11 comes out, there are two choices. First is where you can say, I don't care about it, just upgrade me to the latest version, and whenever it's available, we'll take care of the upgrades for you on the control plane side. Or you can say, I really want to specify when the upgrade needs to happen, in which case it's your control. So then you manually say, okay, now upgrade the cluster, and we take care of it. In either case, it's a rolling upgrade, and there is no downtime in the cluster at all, or at least in the API server, because we do roll it one at a time, and that's the important aspect. That's an important aspect for our customers. Now, come on the data plane side of it. On the data plane side of it, because you manage the worker nodes, we provide you scripts on how those worker nodes need to be recycled. So once again, you do a rolling upgrade of those worker nodes, and one by one, each worker node is upgraded. That's sort of the philosophy. Any questions so far?
So on worker nodes, it's probably Kubernetes something you got to upgrade it, right? That's a 1.10 to 1.11.
Well, that's not the way we look at it though. It's an immutable infrastructure, so we really tear down the worker and bring in a new worker in.
Bring in a worker in.
Because it's an immutable infrastructure, there's no point in updating it in place.
Okay.
There are more risks associated with it.
Is there any problem, like if my master is running on 1.10 and master is running on 1.11, but worker nodes are running with 1.10?
So that is a usual testing that happens in SIG testing at Kubernetes. So if there are any issues like that, then of course, that all gets fixed up in the upstream itself. And that's not the power of open source. I mean, you're not the only one responsible for it, because it's used at such a wide scale. Hopefully somebody else will report it, and then it gets fixed. And if it gets up in a sort of a minor release, then you automatically get all the benefits.
Two questions. Can you cleanly insert a Cni plugin when you're using kubectl to launch a cluster in the second version?
No, there is no, when you get a managed Kubernetes cluster, when you get a managed EKS cluster, then the Cni plugin that we have is the only one that you get. You don't have a choice of inserting your own Cni plugin.
Okay, and then what was the relation between Cni and Tigera, the way you're using it? You're saying...
Calico.
No, even Tigera or Calico or what?
Yeah, what's this, the default, you said the default was Calico, right? Is that what you said?
Calico is only for firewalls though.
Oh, only for the firewall.
The Cni plugin is the one that we wrote and out in the open source. Calico is sort of the firewall part of it.
Specific. Okay.
Yeah, and Cni is a separate mechanism, which is an AWS mechanism on how those IP addresses are assigned.
Yeah.
and then used by the Cni plugin to be attached to the pod.
Okay, gotcha.
Yeah.
EKS, then we can still use Calico, right?
Yeah, of course. I mean, again, Calico has a Cni plugin as well,
Okay.
and a firewall. We only use a firewall part. The Cni plugin is
It's
only ours.
supported by it.
Yeah. One of the ways that we have looked at it is, for example, Cni plugin is essentially installed as a daemon set. You can remove the daemon set and you can custom install your own daemon sets and use this plugin. But that's an unsupported configuration. So you're on your own. And the important part to understand is, on the managed control plane, you don't have access to the EC2 instances. It's only on the worker nodes and what you want to do. Because with worker nodes, what we do is we give you a pre-configured armies, and those armies have everything baked in, Docker, kubelet, everything that you need it for it. Let's see what all slides I have. I can keep going on. I can keep talking about this. Nick, how much time do we have?
10 more minutes.
Few more. Okay. Well, I'll keep going then. How does auto-scaling works with EKS? Let's take a look. Let's take it to the application side. On the application side, we have this usual concept of HPA, or horizontal pod autoscaler, where you can define how should the deployment in my application scale. Because when you do a deployment, when you say, oh, 3 replicas, and what if my replicas are not able to serve my customer request? So then what you can do is you can set up the metrics. So much CPU, so much memory, automatically scale up. You can set up the minimum and the maximum threshold that I want the number of replicas to be between 3 and 10 essentially. And how do you scale up and scale down based upon this CPU and the memory metrics? Something new that is added to 1.10 essentially, which is pretty cool, and I've been thinking of writing a blog around this, is custom metrics. Now these are the custom metrics that is generated by your application. So you're making the HPA a bit more intelligent about your application. So I think that's a pretty cool feature, as opposed to just saying CPU and memory, because I could have a completely different metrics that is my application specific.
Can you elaborate on that? Like, how can you define those? Can you elaborate on how can you define those?
I have not. I just saw this feature coming out of 1.10, and I just heard it in the podcast. So that's been on my list to kind of play with it. So stay tuned for us. Keep us honest. We will hopefully write a blog on this soon. On the cluster autoscaling, there is of course native autoscaling that you can use, where you can use tools like cluster autoscaler. So like in case there is cluster autoscaler is a plugin that you can install on your worker nodes, and if you realize that your worker nodes are running out of capacity, it will automatically scale the worker nodes. And of course we have the autoscaling groups, which is the usual Amazon syntax or AWS syntax. So like in case a worker node goes down, it automatically scales up. It has those usual CloudWatch metrics based upon which it can scale your worker node very easily. Let's take a look at a little bit about load balancing options. And once again, the beauty of this is everything that is done in the upstream is available to you. At Amazon, we have 3 different kinds of load balancer. There is a classic ELB, that was the first one that we introduced. Then there is application load balancer. And then there is a network load balancer, which was introduced in September of last year. Now, one of the joys of the open source community is how the person who added support for NLB in Kubernetes now works at the EKS team. So we love that part, because we don't have to really do a lot of resume check. The guy has really all the credits. He knows the Kubernetes code base, and now whatever he was doing out of passion, he's actually getting paid for it. So classic ELB and NLB are simple. Then there's an ingress controller, which is by CoreOS essentially, where you can do application load balancing. The problem with, or the issue with, say, classic load balancer is, in your deployment spec, you can say type : load balancer, and that will spin up a new load balancer for you for each service. So if you have a lot of services running, you have a lot of load balancers running, and that could quickly add up to your cost. With ELB ingress controller, what you can say is you can define one ingress controller, and then you can do a path-based routing. This is sort of a layer 7 routing, and that the classic ELB is a more layer 4 routing. So that's sort of the advantage. So literally one ingress controller can handle all of your applications and very easily do the application-based load balancing. One of the efforts that we have done is we have moved CoreOS ELB ingress controller That's the one that we are looking at to support as part of EKS. That project has already moved under SIG AWS, which is sort of where all the AWS related work happens in the Kubernetes community. And we're going to be actively working over there and see how eventually it will be integrated as part of EKS. So we talked briefly about customers. These are some of the customers that we worked with, and this is only during limited preview, by the way. You should really, we are working with each one of them now to create a sort of a reference account. GoDaddy story is particularly very interesting. You know, they're all in AWS customer. I have a funny story. 4 months back, we were invited to GoDaddy. So me and the EKS product manager, we were invited to GoDaddy, saying that, okay, you know what, you need to go and talk about EKS over there. Oh, by the way, 2 days back, Satya Nadella was there as well, and he was pitching AKS. So you're going to beat him over there. So we go over there, you know what, we're going to dress up our best, and that's all we can do at this point. It's very hard to beat that, but it was really, I wouldn't say a surprise, but we really enjoyed when we saw email from the account team that GoDaddy actually chose EKS as the preferred cloud provider. So GoDaddy now is an all-in AWS, was always an all-in AWS, but now they're going to deploy their applications on a Kubernetes cluster running on EKS.
Did they mention why?
I guess they must have liked us. It's about customer obsession, I guess. So that, we really enjoyed having we really had a long discussion with them, went into all the details of EKS, what we can do, what we can provide. And we love the part where we listen to customers and we innovate on their behalf to help them innovate further.
As far as customer adoption, are there plans for any migration tools, let's say from ECS cluster to this one?
Yeah, so I think that's an interesting question, migration from ECS cluster to Kubernetes. I think you really want to think about what is the business case that you're solving, or is that more of a hypothetical question? I always look at it from the point of view, what is the problem that you're trying to solve? Or is this more of a golden hammer question that, oh, now EKS, everything is a Kubernetes cluster now. As I said earlier, a lot of our customers around the world are using ECS pretty heavily. At any given week, there are hundreds of millions of containers that are launched on ECS. Now, if you only care about, for example, running your cluster where you don't care about the API, where you don't care about the underlying infrastructure, you don't have a need for on-prem, go with ECS, fully managed, deeply integrated. That's the primary reason services like SageMaker, Batch, or Code Build are built on top of ECS because it's known to scale. It's a highly multi-tenant, singular control, and just works very well. If things like PCI, HIPAA compliance are requirements, they sit right now in ECS, and again, a much deeper integration. Now, doesn't mean that those services will not come to EKS, they will, but they will take their own course. So I think that's the way I would look at it. ECS is not going anywhere. We are continuing to invest into it. As a matter of fact, today, Fargate is only available to work with ECS. I think somebody also asked the question around EKS plus Fargate. Now, EKS plus Fargate is a little bit more intense question because if you think about the Kubernetes architecture, everything is surrounded around the concept of a node. It says there is a node. Node could be a master or a worker. Node is where the kubelet is installed. When you install a deployment or a pod, you can say the affinity or an anti-affinity for a pod. So there's a lot of concepts, core concepts around node that are existing in the world of Kubernetes. Bring Fargate, there is no concept of a node because all we're saying is create a cluster and I can run the pod. You just run the pod for me. You scale the cluster for me automatically. I don't want to be bothered about what's running and what's not running, what kind of cluster is running. So that's where the discussions need to happen in the Kubernetes community. So about 2 weeks back, a node-less working group was formed in the Kubernetes community, and the discussions are happening. What does the concept of a node-less really mean in the context of Kubernetes? Now, there's a project out in the open source by the name Virtual Kubelet, which allows you to spin up a kubelet backed by any provider or any set of compute resources. So what we have done is we have sent a pull request as a Fargate provider to the virtual kubelet. So essentially you can say, I'm going to fire up virtual kubelet and to virtual kubelet, I can say, go run my pod in a Fargate mode. So then there is no concept of a cluster. We manage the entire cluster for you, and that's another pull request that was merged into virtual kubelet. So that's something, a very early work, proof of concept, pre-alpha work that we've been doing in the community. But again, majority of the discussion needs to happen in SIG node, SIG architecture, nodeless working group now, and see how it evolves. Going back to our core tenet, contribute back to upstream. Amazon has a huge partner network. We have hundreds and thousands of partners, SIs and ISVs, all possible ways. And Couchbase is definitely one of the partners over there. You'll learn more about that later today. But these are some of the launch partners that were part of EKS from the very beginning itself. So whether you're looking at monitoring, whether you're looking at security, whether you're looking at stateful sets, whether you're looking at deployment pipelines, a whole lot of names are over here, which were part of the launch itself. Okay, I think I'm going to stop at this one here and see if there are any, well, actually one more slide. And the transition is taking too long. Any questions in the meanwhile?
Is there any work going on? So we have to download a authenticator as well, right? Is there any work going on, like merge this into somewhere like maybe AWS CLI? So right now the problem is we have to explain every team member, hey, download this, download that.
Yeah, absolutely feedback. That's something we are looking very closely. I would say 3 options that we are recommending to our customers today. Weaveworks is a very good partner of AWS. They have created this EKS Scuttle, similar to kubectl, EKS Scuttle API, one CLI, and if you go down here, essentially, just this command. EKS Scuttle create cluster. It does the whole thing for you. Okay. It takes reasonable defaults. Now it creates a VPC, it picks up the rollout, all of that for you, and that's it. So this command is super simple. It gets you started, kind of gives you exactly what all is doing over there, and that just works out of the box. HashiCorp is also one of the launch partners. They launched the Terraform templates by which you can launch a full-blown cluster. And literally this morning I was testing the CloudFormation templates by which again you can do a full-blown end-to-end where you don't have to download anything. Will take care of all the plugin for you. But EKS Scuttle CIO is what we've seen our customers using it. One of the slides I want to talk about here also is people ask us about what are we doing in the open source land essentially. So I just want to highlight some of the open source projects that we have been doing in the community. We talked about the Cni plugin, we talked about the Hefty Authenticator, we talked about virtual kubelet. Bob Wise, who is the GM for EKS service, is also the lead for SIG AWS. We are also actively participating in the cloud provider working group because we really want to take ownership of the AWS code over there, because cloud provider working group is where you're saying, I have this generic Kubernetes concepts, how do they map to a corresponding cloud provider? And that's how the area where we're pitching in. And we are very actively hiring around the world. So if you are interested in working in Kubernetes and open source and want to build a career at Amazon, here's the hiring manager email or talk to me afterwards. Any other questions? All right, then I guess that's a wrap for my presentation. Nick, all yours.
All right, everybody. My name is Shamari Liebert. I'm a cloud architect in the cloud partnerships team in the business development group for Couchbase. So I just joined about 3 months now, so I'm pretty new to this. My background is in just about everything when it comes to development. I was a straight developer, Unix tools developer. I worked on business rules, which is a precursor to, I guess, machine learning. I've been a consultant for a long time in the field. So why am I here and why am I doing this? 2 reasons. Because we work in the cloud partnerships team, is that we do a lot of integrations with other cloud providers, and we are excited to be a launch partner for the EKS product. And during the beta and the launch, I was the person who did a simple write-up on how to integrate the Couchbase operator, which we're going to talk about, and EKS. So there's a GitHub link for that, and you can see that, I'm sure, in the meetups and information. So what we're going to do today is go through part of a walkthrough of what you would do if you were trying to integrate Couchbase with EKS. Now, I wasn't aware of course, what Arun was going to do, so I thought that maybe we would have already gone through how to set up an EKS cluster. We didn't do that exactly, but it takes a while for a lot of these things to get set up, so I don't want to do that and have you guys look at me wait for like 10 minutes while I get it set up. So I already set up the EKS part of it already, and we'll go straight to the Couchbase operator and the Couchbase cluster part. Now, it's going to be pretty quick, and that's the whole point. You want it to get, you want it to be pretty simple. That's why we're using Kubernetes, and that's why we use the operator in the first place. So let's just go over the EKS part, what I did. The biggest part is I just went to the Getting Started Amazon EKS page. It has everything you need. It's a bunch of steps, how to get the EKS running and how to get set up. And that includes your kubectl and everything else you need. I've done all those steps like I mentioned. So what do I have? I have the VPC you need, already created. As Arun mentioned, you need some worker nodes. I have that set up. And also my EKS cluster. So we're all ready to go there. All right. So, and that also includes the Heptio authenticator and everything like that. Everything's running right now. We're just going to start from there. So, let's clear this. All right. So let's see what we have. First thing we need to check is let's just see that's, no, version here. Oh, it's small, I'm sorry. You can't see it? Okay. Let's see if I can. It's supposed to be the right size here. What happened here? Let's see, what can I do here? What can I do? I have some settings here that can help you.
Command plus plus.
Okay.
Yeah. Yeah. More. Keep going. Keep going.
Now? Two more? Okay. Okay, can you see now? The good thing about it is I can't see, so I can't tell. Thank you for that. All right. I think this is right. So as mentioned, you need to have kubectl 110 or higher. So we already have that installed. Now, I don't know how many people here are familiar with kubectl and Kubernetes. So there's some configuration that's set up on that. Like, we're going to go past the configuration. If you want to see the configuration, just raise your hand. We can go back and look at it. But let's just pretend like we're ready. We're set up. We have everything here, kubectl, EKS, and we're ready to go. All right, so first thing is we're talking about Couchbase, the Couchbase operator. So what's that? So Kubernetes says an operator represents human operational knowledge in software to reliably manage an application. So what does that mean? Basically, it's an application that's managing a specific type of application. So in our case, we're going to have an operator that helps you manage how you manage the Couchbase cluster itself. So it's going to be setting up configurations. It's going to handle a lot of the auto recovery and things like that you need. It's going to make it simple for you. You just do it through configuration in YAML, and that's all you really need to do. And that's where you want to get to. We're going to show how to install the operator, and then we're going to show Couchbase running. All right. So let's start it off. So I've already downloaded a certain amount of files you need here. And there's a few things. Before Arun mentioned the RBAC part. So you have to deal with RBAC also with Kubernetes. And what we're going to do here is we're going to do a few things. We're going to set up a service account, right, which is basically identity that you need to tell Kubernetes, you know, this is going to do whatever permissions you want to set to it. So we have to make the service account. So we have that file here. And oh, it's still there. Okay. So I'm going to be doing that all day. Let's try again. I'm going to do too bad. So let's try here. Good? All right, so now we can see it. All right, so yeah, so the service account, pretty simple, all YAML, nothing fancy here. You see I have it numbered so we can see. Now the cluster role. Essentially what the cluster role is doing here, we're gonna have two things happening here. You could do it based on the namespace. So in Kubernetes, you have this namespace concept that you guys are probably familiar with. Basically a way for you to separate different applications within a Kubernetes cluster. In our case here, what we're gonna do is we're gonna set, cluster role lets you set the rules around a cluster-wide configuration. You could do it also for a role, but we're just gonna use a cluster role here because it's simpler. So we're basically just setting up what that identity we created, what it can do, right? It's just giving you some correct, that's what it is, role-based access control. And we set that up and we'll be ready to go here. So what we have is type of cluster role, there's information for it. And we're also now gonna do the role binding, and that's just applying those rules to this role. All right, so let's do some basic kubectl commands here. So you see it. So the apply, obviously, we use a declarative method. We're just going to apply a bunch of YAMLs here. We talked about the service. Can I type? And it is, there we go. All right. All right, actually, let's see. Before we do that, let's see what parts we have. We have nothing here. Good. So nothing's running. All right. So now we also talked about the cluster role. Add that. So if you've used this, you know, you're going to hit apply all day. And I'm no different with that. Again, this is the role and the binding. All right. So we have that. Now, let's take a look at the operator. So here, what I had to do is I had to, from my experience, if I don't set this up correctly right now, in terms of putting that service account and then the cluster role and the binding, when I run the operator, it's going to get frozen because it can't do anything in the cluster in the first place. So you make sure you apply that first, and then now we're going to run the operator. So now with that, you need to put some configuration from the EKS cluster within this YAML file for the operator to run. And really, it's right here. It's two things. And in the write-up, we give you an example and give you a template. So what we hear, you're gonna say the Couchbase operator is what we're gonna apply it to, and you have to put your EKS's endpoint. So where we get that from? Right here, from the cluster we created earlier. So all of this is, obviously we have to link it into our kubectl configuration. And I've obviously already did that, so that should work. Just check to make sure that looks right. Everything else is pretty boilerplate, nothing fancy. And I know looking at configuration files isn't the most fun thing to do, so if you want me to stop and show you what's anything else about the configuration, we can do that also.
Yeah, you might have explained this. Where did the operator YAML file come from? Is that generated or did you work from a template?
Yeah, it's from, you have to generate it. I mean, but we have a template we provide if you would like to use it. Yeah. So normally, and in the walkthrough we have that. We have the S3 location. You could download it and you can edit it. But to make the presentation a little simpler, I downloaded all the files here already. Anyway, but good question. So we're going to use a new command, apply, not that new, but we've seen it many times already. All right. All right, so let's see if that actually, all right, so that's not, what we want to see is available. Skip a little while, so make sure that works. There we go. So if we didn't do the RBAC part before, what would happen a lot of times, you just see it right in here, and this would never come available. And it's a pain to understand. You have to go through the logs and take a look at what's happening, and it gives you some not that helpful log statements. So trust me, you definitely want to make sure that RBAC is set up first, and then you can worry about getting the operator to work. All right, so now we have the operator running. Now the next goal of us is that we just want to get the Couchbase clusters running. All right, so let's take a look back on here. Sorry, back and forth. So let's see, we have anything running? Nothing. There we go. So we can see that the operator now is running. Remember I ran it earlier. Nothing was there. It's all setting. No restarts, everything's good. All right, so now we want to work on the Couchbase. No, let me leave that here. It's fine if you guys see it. Okay. So we have to apply a secret, pass credentials for the Couchbase cluster. All right, all set up here. I'll show you how that looks. Go apply. So I guess I get tired of typing apply already and I forget. All right. So nothing interesting here. It's just some credentials are being passed. All right.
So that's the encoded password to access the Couchbase GUI.
Mm-hmm.
That's what it is. And this step and the previous step, they are one-time operations. So you just define the operator once and your authentication one time. And from that point onwards, you can just have your YAML file, which Shimori will show. You can just deploy your multiple Couchbase clusters after that.
Right.
That's the power of this platform.
Well, what's the point of obfuscating the user?
Because we don't want to save in the clear text.
It's just basic before or what?
Yeah, just basic encoding. Yeah. But then we can always change it, right? I mean, it's easier to store this way than storing in clear text. And then you will be saving these passwords in your repo. So it's like a shared.
That's what Kubernetes supports.
From security point of view, just wasting your time, right?
But then you understand in the cloud, the security is a shared responsibility model, right? So if you are managing your repo, you're gonna manage your cluster for Amazon or even the applications running on it. I mean, at one point, the user is responsible for their securing their own assets.
Yeah, and if somebody has access to your machine to this level, you're probably in trouble already anyway, right? So it's not really a security issue. The security issue is don't let them have access to this machine at that point, or these clusters.
I'm saying I think you make it more difficult to use and you're not adding any value.
That's true, I guess, is a perspective. Well, that's true. But at least it's not clear text. Close enough. Almost. I don't know, I agree.
Equal sign.
There it is. All right, so now this is all the configuration for the actual Couchbase cluster, right? So this is where we want to get to. We did the operator, which is the part that's going to help manage the Couchbase cluster. Yeah, we talked about the credentials here. And this is the part we would be changing as an administrator, the Couchbase cluster here, right? This is what we want to really get to. All the settings we're going to need. So what we're going to look at right here is we're going to see that we have right now the auto failover timeout at 30. We're going to talk about that later. Just run this. And the famous apply. Right, this should run. See what we have. So it's coming up. Could do a watch, but I don't. Let's wait a little while and let's get running. Okay. Still creating a few of those. All right. It's going to be running. So we'll see that in a second. We'll see all of those. Now we're going to do now, since this should be running, it's going to come up over time. Go over here. We got the port. What we want to try to do now is we need to find a way in order for us to be able to access the web UI. So we can do a port forward on that. So you see, we basically did a few commands, and we're already almost to that point where we're ready. Go forward and check this format correct. All right. It did? Of course it did. I can fix that part now, thanks to you guys. All right. Yep. Should still get the type. All right, so what we just, obviously this is pretty self-explanatory. Opening the ports we need in order for us to be able to access the web UI. All right, so let's hit it. If I did, it's not running it. Okay, just gonna check that out. Did something fail here? Or did I type it wrong?
4 zeros?
Yeah, I typed it wrong. So I can put 3, I think. Yes, I did. Thank you for that. All right, let's see. Okay, looks good, right? All right, so now we have to leave this open while that happens. Now we're just gonna need to, it's running, good. All right, so we're gonna see, we should see is there we go. So the web UI, so basically right now, Couchbase is running, and we barely did anything, which is the point. All right, I don't want to do that. All right, doesn't matter. All right, so we will do it. So, okay, we have 3 here. Okay. A little bit of this. All right, so you see that the pods match the pods that we have here. So we're running now. Everything's working, looks good. Everything's up. So from those few commands, we already have the Couchbase cluster up. Now, that's good in itself. You can start a Couchbase cluster declaratively through that config. But even though right now Couchbase Operator is in beta, so it means other features added. Right now, what we want to do is we can talk about that property you managed earlier. We're going to do 2 changes here. Oh, actually, just 1. So, all right. So here, we're going to check this out first. Let's see the auto fill over time. Let's go to settings.
Tab on the top.
Yes, autofill, there we go. 30, okay. So part of the power here is that we should be able to just change this config file. Let's do that. And on the fly, that should change. Save it. Apply the same file. And since we're using it in a declarative manner, apply it again. Nothing else, just apply to Couchbase cluster. Make sure I have the name correct here. All right. So we're going to do that change. All right. So we should get in about 30 seconds here. We should see this update. Just click back over here just to see the service. There you go. You see it changes to 5. So now what you're gonna means now it's easier for you to manage everything through that configuration file. That's number 1. Eventually, what I'm told, and Ram can correct me about this, what we can do is you can have versioning of the configs in one location. So you don't have to worry about doing it in the web UI, then somebody else comes and does it through the REST API. You can have one location for that. There'll be versions you could compare and merge and see what the current settings are using the operator's config. You're also going to be able to set some settings where in that YAML file, if you don't want to be able to change some of these things, you can put a block on that, and you can only manage it through the other methods. So it depends on what you want to do. It's going to give you some flexibility between your options, what you want to do. But essentially, now we're running this. We didn't do much, and we're up. Now, what I would like to do, see, I have Bram help me with this part. All right, so let's do this one. Okay, so that would be, I think, delete let's try one, right? It should work. Let's,
001.
the one, okay.
The port service running on.
On 0, okay, right. Okay.
So we are simulating the service failure here. Since we are a clustered solution, it's possible that we can lose a node, and it's okay to lose a node because failures happen all the time. But what we get with this platform is that the power that the administrator basically can just keep sleeping on over the night, doesn't have to get up at 2 o'clock in the morning, so that cluster has not lost a node. As of now, if you're running on a VM, you lose a VM, somebody has to get up, spin up a new VM, add it back to the cluster, rebalance the cluster, but all that functionality now we have defined in our operator. So operator understands our workflow, and we have integrated natively with Kubernetes, and Kubernetes takes care of the work for us. So what we are doing is we just created a pod, which is a kind of node for us. We added that node to the cluster, we rebalance the cluster, and application side will not even see that this happened. So this platform really takes care of the mundane operations from the administrator. So this is extremely powerful what we just saw.
Absolutely, and it happened so fast actually, so you guys missed it whenever I was in. But basically, yeah, you saw it was, one of them was down, the old one was down. Well, you actually can see the numbers have changed now. So it was down, and it caught that in 5 seconds, because that's what I changed the setting to. And then it brought the new one up right away, and rebalanced it, like Ram mentioned, without doing anything other than just having this, I mean, it just did it on its own, based on the configuration. Now, because it's just a few steps here, and it seems like I'm just doing some YAML, but imagine, I did all of that from nothing to full cluster that has auto recovery with about 6 steps, right? And that the power of that is immense. If you had to manage this cluster yourself, imagine the work you had to do. You had to notice this was happening, the monitoring around it, everything else. I mean, of course, you get auto rebalance in other ways, but here, it was just a YAML configuration. You apply it however you want to on the fly, and it works out of the box, no problem. And
the cluster duplicate, was that local like Minikube, or was that, because I see local hosts there, right? Or do you have another example where we can see it on AWS, EKS?
no, this is EKS. This is not Minikube.
Use EKS, right?
Yeah. So remember in the beginning I mentioned that I put the configuration. So I am actually linked to the EKS. That actual.
You can just run kubectl cluster info.
Yeah.
Run that command so that you get the kube config context. Kubectl cluster info, cluster hyphen info. Yeah.
Or,
You've created a tunnel with the proxy command.
Yeah.
It looks like localhost, but basically it's a tunnel.
right. So
Can you like probably like do a deeper dive on the AWS side just to show for that cluster? Can we see something more like there?
like, what would you like to see?
Whatever, maybe pods. Just to see EKS.
Yeah. Go to EC2. Go to EC2 config page. Yeah. You can see that. Yeah.
The EKS, you see the worker nodes is what you see.
Yeah. Just go here.
You just,
No, this is Cloud Foundation. Go to EC2 service.
yeah, I'm not familiar with. Okay.
Sure. No, I can guide
Okay.
you to this. No problem. No, on that page itself, on
Okay.
the previous page, yeah. Click on services. See services tab. Click on EC2. The first one under complete. Yeah. And here click on 6 running instances. See that? There you go. So expand the first tab. So here we will see that we have we should see the Kubernetes master and the worker. So what Shimuri has done is he has created that cluster beforehand, because we don't want to see the cluster created, there is no value in it. But just like it's a straight one command, you create the cluster, and then you get this Kubernetes master. And when he does the kubectl here, so the kube config from the Amazon EKS gets shifted locally. So now your kubectl understand that he's talking to the master running on Amazon EKS.
Right. Oh, sorry. Yeah. So.
In this case, when the node was down, it's basically a virtual machine was down, correct?
No, a pod.
A pod was down.
So we
okay, what
have-
if VM was down? Will it spin another VM?
If one of the worker nodes drop?
That's what the Amazon EKS does. So
EKS.
if you lose masters from Amazon side, they will, since it's a managed service, they're constantly monitoring the service.
Right.
So in this Couchbase managed thing, it doesn't, right?
No, it will do it. It will manage all the masters for you.
Well,
Okay.
there's 2 levels here. So the reason why, I mean, even when you do it in EKS, you don't need to ever come to this screen, right? Usually you would just be doing it from this level, the cluster. That's being managed behind the scene. It's doing all of the auto rebalancing and everything. That's auto recovery itself. In terms of just the control plane and the worker nodes is handling Kubernetes management, right? Our operators is only handling Couchbase management. So it's not dealing with any of this. It's just dealing with the Couchbase cluster itself being recovered. So ours is specific to Couchbase. This is specific to the EKS managed service, which is trying to hide what you just saw from you. It's trying to make sure you don't have to manage that. That's why we use EKS, right? So you want to make sure that if you don't want to deal with Kubernetes, you use EKS. You set it up one time, and then now things just magically happen. You have Kubernetes cluster up. And then use the operator, go ahead.
How do you add a new node, like new Couchbase node?
You just add it here. So Amazon EK is a managed service that is giving you ability to create the Kubernetes cluster. So if you want to talk to the Kubernetes cluster, you just talk from here. You just define that, okay, I want a Kubernetes cluster with, say, 3 masters in these availability zones and these are number of nodes. And so that your one application is user profiles, okay? Another application could be their authentications or their data. So what you will do is, and if you want to have 2 Couchbase clusters for that, you can just define like 2 EKS clusters, one for the user authentication and one for the data. And then you can have Couchbase clusters running on them separately or just one cluster running 2 Couchbase clusters, that's okay too. But then you have to size it. So all they are saying that they will hide the complexity of managing these clusters for you so that you just deal with what your application is.
Right.
My question was, how do you add more nodes to the Couchbase?
Oh, that's what the YAML file.
He's going to show you that. Yeah.
Oh, well, we actually, I wasn't trying to, but I mean, it's all through the YAML file. So here, see, we define your cluster. So he could have also broken it down to how many index nodes and whatever
Just do
else.
it, just put 5 there.
Okay.
Put 5 and apply.
Yeah, let's apply. You want the number to go up? Okay, sure, we do it. No problem.
So for Couchbase nodes, all you have to do is change the YAML files, and that's when I said that you will just standardize on your YAML files. For example, app team will have one, or service level will have one, web front team will have one YAML file. So you can just integrate this in your CI/CD pipelines. So you test your code, you test your application, and you just call the YAML file that you need for the Couchbase cluster supporting the app. So this process can be automated.
Quick question. So it's also the VPC space, does it require its own VPC or you can use
The EKS creates the VPC for you.
See, there we go. So you can see them popping up now.
Yeah.
So we just changed it from 3 to 5, and here they go.
Because you want to secure data, right? So it makes sense to put them in a VPC.
And yeah, so, and I guess,
Can I use an existing VPC?
I think
no,
as
you
long
can,
as-
but they want you to use one for this. Typically is what it is. They say they wanted to isolate it. That's what it said in the getting started, but I'm sure you could, but I don't think that's the,
Yeah, thinking about it,
Mhm.
if I have to talk to any existing services that I have and other VPCs, then I need to do VPC pairing and stuff.
Yes. So we need to look into as in what capabilities the Amazon EKS supports.
Yeah.
If they support using existing VPC, it should not be a difficult, in my opinion. But yeah, you can
Yeah,
use it.
thanks. Sure.
So how do clients discover this cluster?
So you will get a cluster URL and you will publicize that cluster URL to your
Yep.
apps.
Mhm.
So and everything in our platform is REST based. So at the end of the day, we are a REST endpoint. You'll have your authentication mechanism, and your app will just call that REST URL with the user credentials.
So this is like some DNS.
Exactly.
Yeah, the client does not know the IP of the newly added server. It knows the old one, that's fine, because it gets that entire cluster again, and there is a rebalance that.
Exactly. So essentially that's it. Pretty simple. And Ram added some complexity, and that was simple also. So yeah, so it's 2 things. EKS part we didn't see, which is, I think maybe I should have shown that, but that takes, like I said, a while. Sorry.
I assume that each pod is running on one EC2 server.
Not necessarily.
Not consistent.
Let's show that in this case, is it?
We looked at it earlier, right? Did we
We
see?
can check it out.
No, there were three.
Go back to the EC2 service.
Yeah, it was 3
It's
actually.
all
We saw.
running on 3 workloads. So
Yeah,
that means
yeah.
one EC2 node can have
Multiple pods. So that's where the ANI comes, each pod gets its own.
That's it. They are constant.
okay, okay.
Yeah.
I get that. So in case if I lose the entire VM, EKS has to take care of that. So I need I use a Couchbase server,
The operator will take care of it.
yeah.
Yes.
Okay, got it.
So service resiliency is built on multiple levels. From EKS side, since it's a managed service,
Yes.
they are doing their hard work to make sure that the infrastructure is available for us, and we are doing the hard, heavy lifting of making sure that we have tight integration with Kubernetes, so that our workflows are defined well within the Kubernetes operator. So any changes in the workflow, all Kubernetes API is doing is watching that YAML file.
Okay.
Any change in definition will be watched and corrective action will be taken.
Okay, and as best practice, what do I do? One node, one pod for a virtual machine, or multiple pods on a virtual machine?
So,
as best practice in production.
So depends on what kind of sizing we come up with. Say that you are coming up with a sizing of, say, your pod needs to be, say, 4 core, 16 GB RAM. So in that case, then we will choose appropriate instances. But again, this is very subjective to the use case that we want to support on that. If it's just a web content, it doesn't matter. You can put I think this is a T2 medium, very lightweight VM, and we can see that it's already supporting like 7 pods.
And that was just random choice.
Yeah.
It can be whatever you want, yes. Okay.
Container registry, assuming that was CCR.
Yeah, so we have integration with that. So basically, you will just, whatever images you have, you store it there, and then you can call the images from the Amazon Container Registry.
You had a question?
Yeah.
So here, what in fact is what they
It's fine. But in the second, assuming this context that you're running containers, you're never going to try to recover them now with the tails off, or you're just running them in.
So you want to know the actual original node is being brought back up other than creating a new one and rebalancing it. Is that what you're asking?
Yeah, do you ever bring a failed container back in, or do you always just?
I think it's just a new one is always created, I'm pretty sure.
It's always a new.
Yeah, it's always going to be a new one because it's going to check the heartbeat and know it's down. It's going to create a new one to match whatever your settings were in that YAML file. So it's not recovering that way, in the way you were talking about. It's a good question because that means you have to size your cluster based on expecting this to happen and have more CPU available in order to deal with this if it does happen. But that's always the case anyway. It's just that here it's a little bit more less transparent.
Well, the more equal explanation question, if the node fails for some unknown hardware problem, and you try to bring it back into the cluster, you can create a problem because you're working with containers. There's something wrong with the node. Just get rid of it. Bring in a new node.
Absolutely. Mm-hmm. And even before containers, or even if however you do it, still that problem is always there. If something goes down and it's because of a catastrophic failure, you still have to figure that out later. But the recovery is the first step, right? If you try to recover it and it fails, then you have to decide, well, what are we going to do at this point? Because maybe we can't bring it up to 4 nodes that we need. And if that's the case, where you need 4 nodes, you can't bring it back, you might be in trouble based on your sizing in the first place. Sure.
So, before Kubernetes, how did Couchbase recover? Couchbase is a pretty good solid database, right? So, how do you recover it if you more fail in a data center? Before Kubernetes.
So we had auto recovery. Go ahead.
So it depends what kind of use case you have. So we have by default one replica. So for every document that you have in your database, you have a replica for that. So if it is whatever node cluster you have, if it is 3 node cluster, it will sustain single node period. At that time, cluster is running in degraded mode. There is no data loss, and that's how we will have the service resiliency. At that time, administrator has a choice either to bring the same node up or add a new node.
I think earlier with Couchbase, what it provided was auto failover. It provided by default, but with Kubernetes, what you get is auto recovery as well as
Yes, that's
I think that's the and auto scaling is what we get.
Any guidelines with respect to volume persistence or
Oh, that's not available yet, but it's going to be the next thing in number version 1, right? PVC is going to be there.
August, so we are stateful. But early August, when we GA this our offering, and we will be supporting for system volumes.
Right. Yeah, so that's a good point because that means that right now it's ephemeral, right? You mean if it goes down, everything goes down, there's nowhere to recover. But when we have PVC, that would be just like you're used to. But that's what we expected.
But since they use the PVC, it will belong to the pod
whatever storage class supported by Kubernetes.
Yeah.
Yeah.
So previously will be part of the cluster, not necessarily the app or any parts.
So at app level, you'll take a claim. So app is Couchbase. So Couchbase will take a claim on that PVs and it will give that ownership to the individual pod.
Right.
So if you lose a pod, that pod will go away. But when a new pod comes up, it will say, okay, where is my ownership for the PV?
Right.
We claim that so that the node mount will be faster.
Yeah, it'll just basically mount to whatever's available there. Yeah.
But you get to choose the kind of disk.
Absolutely. Yeah.
Yes.
There is a storage class API, and with that you can choose whatever IOPS you need.
So where is the config did you specify?
It's not there yet. So
It's
you're
not there,
talking
but
about
I'm asking about the current code we have.
Yeah.
Where did you specify which host?
So as of now, it's ephemeral, as Shimori said.
Hmm.
It's ready to the local.
Which instance types you want? I want Couchbase running on let's say C5.
Yeah, you can just pick that. So while creating the EKS cluster, just mention that
Yeah.
you want to create the Amazon EKS cluster on those instance types.
Right. The same thing, because I didn't show that part, it's in when you create the cluster, you can decide what you want it, how you want it to be built. I just picked the
Yeah,
medium.
that's EKS.
Okay.
Yeah. I
Um,
don't want EKS.
Okay,
That's
sorry.
Couchbase. Let's say my EKS cluster has like hundreds of instances.
Okay.
Maybe some C5, some C4.
Mhm.
Now I want the Couchbase specifically on the C5s.
Okay.
How do I specify that?
Oh, so you want the operator Couchbase only to run on a specific type of an instance.
Right.
So you probably use labels. And
yeah, I think it's labeled.
Exactly.
Right.
You can just label that for these kind of applications, you want to use these kind of instances. So you can define that while you are deploying the app itself.
Okay, and that's part of one of these YAMLs.
Yeah.
It's all this YAML. We just need one YAML, but yes, there's a setting for that. I mean, entry. Yep. Yeah. Actually, we don't have it.
Like this would be very challenging and for this R&D to move this controller and storage from AWS to Azure to Google. It's pretty interesting. Yeah.
So the abstraction that Kubernetes gives actually makes it porting
Easier.
much easier.
The real
So for example, the kube control, right? So you could run this Google, and that on Google and Azure has been very easy, right? And now on AWS it's also easy. Previously you would need like other libraries like Cox or CoreOS, whatever. Now with this one, AKS, we pick it. It's easy to do.
Right. All right, so that's essentially the basic ways of running. A bunch of YAMLs, Kubernetes, operator, that's it. I guess all the questions might have been asked so on this side. But that's really the presentation. This is how you do it. I think the part I should have added was to show the EKS part in the beginning, even though it would have been a bit painful, because I think that was slightly a disconnect of what was happening here. But because that was already pre-set up.
Yeah, you showed it actually, but you didn't pay attention.
Yeah. So like I said, but that's also the abstraction you want to have, right? The EKS part is supposed to be kind of ignored. After you set the configuration, you don't really care about it. The managed service is managing it. You just want to care about the Couchbase part. And the operators are letting you ignore some part of that also. That's what we want to get to. It's getting much simpler. That's the whole point of this operator. All right, guys, that's it. All right, thank you.